Okay, so in lesson 4, we learned about solving exponential functions, so bases of numbers, unknowns, and the exponents. Today we're going to also talk about solving logarithmic equations. So x will be typically inside the logarithm, and then we'll have to figure out how to solve for that particular variable. So here's our first example here. We have log of x plus 23 equals log of x plus 3. I want to just mention one more time, because I mentioned this to my other class, but I still had some people doing this on the quiz, and hopefully we all remember this. We talked about this a couple days ago, but you cannot distribute a logarithm inside it's what you're taking the log of, okay? So I want you to not think of log as a multiple, because that's not what it is. It's a function. So log is just simply doing something. Well, really it's asking us 10 to what exponent equals this, right? So it's actually a function that produces an exponent. It's not log times x plus 23. So I don't want to see anybody in these types of questions doing this and then saying this is equal to log of x plus log 23. Okay? Also, sums become products. This doesn't quite work because I have to have two logarithms with the same base being added. Then I can put them as products. So I cannot write this as a product because I don't have log of x plus log of 23. If I had something like this, then I could write this as the log of x times 23, right? But if I have sums inside a logarithm, those don't become products. It's just the sum of two logarithms with the same base or more. Okay, so given that we can't expand, there's not really many log rules that we can use here, except for if I have a 2 in front, I could do something to this. Any ideas of what we might do to start with that 2 there? Surwa? Yeah, let's bring it up as an exponent. And then we're going to sort of use something that's similar to an exponent idea that we talked about, and that is that if I have two logarithms with the same base, so log of something equals log of something else, what do I know about the two somethings inside the logarithms? What has to be true? Keaton? They must be equal because these are both logarithms with base 10. And if I'm saying the log of this equals the log of this, this must be the same, right? So actually in these types of questions, I can just say, by using my own logic, I know that if the logarithms have the same base, then the insides of those logarithms must be equal. Okay, that's this rule here. Two logarithms with the same base of a and b must mean that a equals b. Okay, so let's just solve for x now. So I'm going to expand over here. This is not x squared plus 9. I don't distribute a squared, just like I don't distribute a logarithm. Squared means times that thing by itself. Then you need to FOIL. When I want to solve something with x's and I can't isolate for x, usually I want to at least get one side set equal to 0. So I'm going to move over the x and the 23 and just simplify here. And I have a couple options. I can try to factor this. If the factoring doesn't work, I go quadratic formula. So multiplies to negative 14 adds to positive 5. Do we have any numbers? Michael? 7 and negative 2 should work. This is easy factoring, right? So we can just go right to the next step. 0 equals x plus 7, x minus 2. And our x's are negative 7 and positive 2. There is one thing that you need to check in logarithmic type questions. I cannot take the log of 0, and I cannot take the log of a negative. So if I sub these back into my original logarithms, and they cause me to take the log of a negative or the log of 0, then that's not a possible solution. That would be like a domain error for these types of functions. So if I sub in -7 here, does that cause me to take the log of a negative? It does. So even if I can sub it into one but not the other, that's still not a possible solution. So I could sub it in here, and I wouldn't be taking the log of a negative there. But if I sub it in here, I'm taking the log of -4, and that's a problem. So this, we would say, is not a possible solution because we can't do the log of a negative when we sub it in. If I sub in 2, are we okay? Are we taking the log of 0 or the log of a negative at all? Okay, then 2 is fine. Okay? So, for instance, when we sub in I'm just making a note here just in case you're looking back at your notes and you're wondering why we crossed that one out. Okay, also if this value happened to cause me to take the log of 0, that would also be a problem. You can always try it on your calculator if you're not sure. But we would, again, consider this like an extraneous root. Bella? No, because you would still, you should be able to, yeah, that's a good question, if the 2 is already up there. I would still say no, because if you have anything that can cause this to be negative in this format or in this format, it's still outside of the domain of the function. So, yeah, I would say no. Any other questions on this one? Okay. So we've got, so in this case, I have simply one logarithm equals another logarithm. And the logarithms are same basis, right? So in this case, I can just set the insides equal and then solve from there. When we get into stuff like this, I have multiple terms here. I have 2 logarithms, and I also have a constant term that's separate from that. So I'm not going to really be able to use that same method here. However, I do have the sum of 2 logarithms with the same base. So what does that mean that we can do? Sir, what? Yeah, I can create a product using product rules. So I can write the multiple of the 2 logarithms. Okay, so I'm just going to make a note here. I wouldn't expect you to be writing all of this. If you were writing like a solution, I'm just going to write it for our notes for right now. So this is product rule. How do I get these x's outside of the logarithm though? I can't really solve for an x if it's inside a logarithm right now. So are there any ideas? Like, is there another way that we could express this? Bella? Okay, so let's switch this into exponential form. What would this look like if we switch it into exponential form? Keaton? Okay. What does this look like in exponential form? Bella? Okay. So the base becomes the base of the exponential. The answer to the logarithm is the exponent. And then what's inside the logarithm will be the answer to the exponential expression there. Okay? Anytime I want to solve for x, I need this side set equal to 0. So I'm going to have to just expand and move everything to one side here. So this is 36. We're going to FOIL here. And I'm going to move that 36 over, so it will become -4 minus 36, which will give me -40. Whoops, that's 3. Okay, so you can see lots of factoring stuff coming back into play here, some of our grade 10 and 11 stuff that we reviewed. Are there any two things that now multiply to -40 and add to +3? So check for factoring first. If not, you go quadratic formula. Multiplies to -40, adds to 3. Bella? 8 and -5. So easy factoring, right into the brackets with the signs. No need to do grouping or anything like that. So x equals -8, x equals +5. Now, just because I get out negative in one of these types of questions doesn't necessarily mean that that will be an extraneous root. It's only if it causes me to take the log of 0 or under back in the original expression. So if I were to sub in -8 into the original logarithms here, does it cause me to take the log of a negative or 0? So that one I would label as an extraneous root. Okay, that one is no. So you can label that as an extraneous root. How about 5? Does that cause me, if I plug this back into both of these logarithms, does that cause me to take the log of 0 or a negative? No, so that one's fine. It could be possible that you get both extraneous roots and then you have no solutions to that expression. That is possible. Okay, or it could be possible that both of them are permissible roots or answers to the expression. Rebecca, you are next to Sam. Oh, wait. You are, yeah, on the other side of Sam. Okay, there we go. Okay. Any ideas for how we can start this part B here? I have two logarithms. They have the same base. They're equal to a constant value. Matt? Okay, so subtractions become divisions. So I'm going to gather these into one logarithm. And then I will do the insides as divisions. X over x minus 4. Okay, how do I get the x's out of the logarithm now? Sarah? Switch it into exponential form. So this was quotient rule. Now we're going to switch into exponential form. 3 is the base. The answer to the logarithm is the exponent. And then it should be equal to what's inside your logarithm there. I would like to get the x to the minus 4 out of the denominator because it's kind of hard to solve for x when it's in a denominator. So I think I'm just going to multiply that on both sides here. That way it cancels on the right-hand side. And then we'll have 9 times x minus 4 equals x. And let's just expand and solve for x here. So bring the 9 in. And isolate. Okay, I would say where possible, you can leave an exact value, so as an exact value. So I would just take this, and I think the largest thing that we can divide into both of these is 4. So this will become 9 over 2. And before I decide for certain that this is a permissible answer, I need to double check that if I sub it in here or in here, that it doesn't cause me to take the log of a negative or 0. Andrew, you're right in front of Clayton there. So 9 over 2 is 4.5. Does that cause me to take the log of 0 or a negative if I plug it into either of these x's? Nope, it doesn't. So we're good with the answer. That's a possible answer. Okay, maybe for your future self, as you're looking at your notes, maybe we should make ourselves a note that just says sub back in to ensure you are not taking the log of 0 or a negative. Okay, any questions so far? Okay, let's scroll. All right, I want you guys to try the first one, see what you can do with that, see if you can get it solved, and then make sure that you indicate any extraneous roots that are not possible. And we'll do B together, but I'll give you a couple seconds for 3A. Clayton?
Start by combining log 6 x minus 5 and then log 6 x. So log 6 and then brackets x minus 5 times x.
Mm-hmm.
And then that simplifies to x squared minus 5x equals 2 log 6. And then I switched into exponential form, get 6 squared equals x squared minus 5x. And then simplify 6 squared, you get 36. And I brought it over, and it's just 5 right.
Okay, good. So sums become products. Sums of two logarithms with the same base, we can write those in a single logarithm as a product. Clayton decided to distribute the x before switching into exponential form, which is totally fine, because you know we will have to expand anyways to get this set equal to 0. So you move the 36 over. You're looking for two things that multiply to 36 and add to 5, which were negative 9 and 4. That means that our x is 9 and negative 4. And you should have indicated that the negative 4 was an extraneous root, because when we sub it back into x and x minus 5, we're taking log base 6 of negative 9 and log base 6 of negative 4, and that's a problem. Okay? How do I check my answer? Bella? Yeah, so we're going to sub in 9 here and 9 here. And what you can do is when you sub in log base 6 of 9 minus 5 plus log base 6 of 9 equals 2, you can actually calculate these logarithms in your calculator by using the change of base formula. So that's an important formula to know, because if I want to calculate something like log base 6 of 4, I need to know that that's actually equal to log 4 over log 6. So you can sub back into check, use the change of base formula quickly there, and double check that you get 2 from adding those two divisions of your logarithms. So that would be the check. I should always know for most of these questions, like the exponential solving questions and the logarithm solving questions, I should be able to check all my answers, and I should be able to know if they're all correct or not. Okay, and then I think we will get 2 equals 2. So that would be what we're looking for. Okay, this one's a different one. It's an interesting one. Any ideas for how we can start something like this? We have this x that we need to solve for that's sort of buried within 2 logarithms now. How do I start this? Bella, idea? I can't divide log of 9 because that's like a function. It's not a multiple, unfortunately. Sarwa?
Can you divide log 4x plus
I can't because, again, it's inside a logarithm. So it's not being multiplied by the log of 9. It's the log of 9, log base 9 of log base 4 of x plus 2. This is not all multiplication.
2? Divide x plus 2.
Nope. It's not a multiple, right? Bella? I feel like that would be kind of complex. I don't think that we want to use change of base, but good thought. Can we start? Let's try to express this in exponential format to start. What would this look like if I were to, so this is the inside of the logarithm. So let's just consider that the inside. How do I express this in exponential format? With this being the inside, this part that I've marked out in blue here. Keaton?
You get 9 to the power of a half.
The entire inside, which is log base 4 of x plus 2. What's 9 to a half? What's that equal to? We can simplify, right? It's just the square root of 9, which is 3.
Why is that square root of 9?
So when I switch this into like radical form, I put 9 here. I have an imaginary exponent of 1, and this is the root. So it's like a square root. Okay, you can also, if you weren't sure about that, you can just calculate it right in your calculator. We'll give you a 3. Okay, I think we can solve something like this. How do I continue from here? Bella? Okay, we're going to do it again, exponential form again. So 4 is the base, 3 is the answer to the logarithm, that becomes the exponent, and it should be equal to what's inside the logarithm, which is x plus 2. I think we can solve this, right? This is 64 equals x plus 2. So x must be 62. Okay, we need to double check by subbing back in. We need to make sure that we don't take the log of a negative here. But also, once we calculate, we don't want to take the log of a negative here either. So if I do the log base 4 of 62 plus 2, so 62 plus 2 equals a half. Log base 4 of 64, what does that equal to? 4 to what exponent equals 64? 3, so this will be 3. Oh, sorry, I wrote 2 here. So is that causing me to take the log of 0 or a negative? Okay, so we're good. So it doesn't cause me to do that here. It doesn't cause me to do that once I've calculated that logarithm. And 9 raised to what exponent equals 3? Well, the square root of 9 equals 3, so the answer to this logarithm must be a half, so that check is good. Okay, or you can calculate log of 3 over log of 9, and that should give you 0.5. Okay, so just maybe for your future notes, we did switch into exponential form. And then we actually did it again. Any questions? Sarah?
Scroll up to example 2. Like the,
B?
like the little boxy thing on the right.
Yeah.
It's by.
Oh yeah, sorry. Forgot to fill that in. So b to the y equals x, yes. All right, we are almost done here. We'll have some good time to work today. All right, so this one's a little bit different than the other ones. This one gives us a piece of information, log base a of b equals 3. Then use log rules to find the value of log base a of a times b squared and log base b of a for part b. We should also make note of something that we discussed the other day, which is what is log base b of b? 1. Why, Serena?
Oh, I don't know.
Why is this true? Bella? Yeah, so really what this is saying is something to what exponent gives us back itself. Well, something to the exponent 1 gives us back itself. So we should also be aware that log base b of b equals 1. And also, if I had log base a of a, same thing, right? As long as the bases are the same, that should equal 1. So I'm just going to make note of that for our question here, just in case we come across that in our travels. Okay, so any ideas for how we can maybe split this apart in some way to sort of try to evaluate some pieces here?
Could you do log AB squared over log AB squared?
I could, but I have information about log base a of b, so I don't want to change the base to 10 if possible. Because if I switch this to log of ab over log of a, then I'm changing the base to 10, and I don't have any information about what those are equal to. So that's a good thought. Amelia? So log base a of a, and products become? So is it multiplied? Close. Emma?
Would it be log AA plus e to the 2 log AB?
Yes. So remember, guys, I have a product inside this logarithm. Products become sums. So I'm writing each as an individual logarithm because I have a product inside. It's a times b squared. And as Amelia mentioned, log base a of a, that's equal to 1. I could also, Emma, do you have an idea from here?
Bring your 2 down to 1.
Yep, let's bring the 2 down. Use power rule. And Emma, finish it off.
2 log A of B is equal to 3, so it's 1 times 2.
Okay, so our question gives us this piece of information. Log base a of b equals 3. So this will be 2 times 3, and that gives us 7. So this is product rule. Products become sums. Any questions for that one? Okay, last one. We know log base a of b is 3. Then we're given log base b of a. These aren't equal to the same thing, right? So just to remind you guys, Keaton had an idea in the previous question to use change of base formula, and I just want to remind you what that is. When we use change of base formula, log base x of y can be log of y over log of x. But I can also choose any base I want. So I can choose any base m, as long as those bases that I choose are the same. When we do log of y over log of x, I'm really choosing the base of 10 when I do that. But I could choose whatever base I wanted. So are there any ideas for how we could use change of base to our benefit here? Sirwa?
Could you do log base A of A over log base A of B?
Yes, we could.
They're not the same size.
Yeah. So I'm going to use the change of base formula, and instead of doing log of a over log of b and choosing the base as 10, I'm going to choose the base as a, because the change of base formula tells me I could choose tens or I could choose anything I want as long as they're the same. So we're just going to choose the base as a. And then, of course, this goes on the bottom and this goes on the top using that change of base formula. And as Sarwa said, log base a of a is 1. And from the question, we know log base a of b is 3. So this will be 1 over 3. Keaton?
Can you also change that into 1 minus 3 if they're divided?
Only if you had log base a of a over b. That's different, right, than subtractions? Okay. Are we good with that one? Any questions there?